example on drying, page number 60. We have drying experiment results happening in a tray dryer containing single tray of 1 square meter. This is the area of dried material. Area is used to dry crystalline solids. So we have crystalline solids like salt, which are wet, and the following data were obtained from the experiment. Now we took samples each time. So we took 8 samples and we recorded the weight of the samples, and the weight is decreasing, which is obvious because the sample is under drying. Now those are the numbers which we are going to get from the experiment. The final target is to calculate the time required to dry the solid material from 20 weight percent to 7 weight percent. So what's the time required to dry the material from 20 weight percent to 7 weight percent? Now to solve this question, we have to complete the table. The first column is we have to calculate W minus LS for each of the samples. The second column we have to calculate delta W. So we have to calculate the weight minus the weight before. That's why the first one does not have any value, because there is no weight before it. So we just subtract 5.162 minus 5.314. We will get 0.15, and we can continue for the rest of the table. Now to calculate the moisture content, we follow the definition of moisture content, which is W minus LS by LS. The value of LS always is shown at the end of the table. So the final number in the table after infinite time of drying, this is called LS, which is the bone dry weight. So if we follow the definition, we will get the following numbers. Then we calculate the rate of drying from definition, which is delta W, which we calculated earlier, divided by the area, which is 1, divided by delta T. And delta T is calculated the time minus the time before. So the time minus time before here is 0.8. So delta T here is 0.8, and delta W here is 0.15. So if we divide them by each other, we will have 0.19. So if we continue for the table, we will notice that the first values are constant, representing constant rate of drying. Then the rate of drying is going to change. It is going to fall down to 0.12. Now if we invert the rate of drying, divide it by 1, we will get the inverse of rate of drying. Now after we complete the table, we can come to the graph and plot a graph between 1 over n against x. We will get the values as follows, and we connect them by using a straight line. By this, we completed the solution of the first part, is to calculate and plot drying rate against moisture content, 1 over n versus x.